All right, let's dive right into this explainer. Today, we're getting hands-on with a DIY cardiovascular physiology lab. If you're the kind of person who loves knowing exactly what's happening under the hood of your own body and you geek out over clear, structured data, well, you're in exactly the right place. We are going to break down how our bodies react to physical stress step by step using the actual parameters of a real exercise physiology assessment. But, before we even look at the data sheets, I want you to stop and ask yourself, how does your heart actually know the difference between a jog and a push-up? I mean, it sounds like a simple question, right? But really think about it. Your body is uniquely built to battle different types of physical strain. When you're absolutely gasping for air on a run versus when your arms are literally trembling under the weight of your own body, your cardiovascular system is responding to two totally different crisis signals. And today, we're going to map out exactly what those signals look like in the numbers.
Okay, part 1, the cardiovascular experiment and setting up your lab.
Consider this your rapid mission briefing. To capture your heart's responses accurately, you literally only need 4 things: a bench step, a heart rate monitor to track those beats per minute, a blood pressure apparatus, a sphygmomanometer, and finally, a stopwatch. That's the whole shebang. So, our core objective here is super clear. We want to observe the exact effects of different types of activity on blood pressure and heart rate. We aren't just checking to see if the heart beats faster, right? We want to quantify the distinct physiological fingerprints of endurance versus strength.
And here's the logical progression of our lab session today. Step 1, we take resting measurements. Step 2, the participant pushes through 2 distinct trials, endurance first and then strength. And step 3, we take measurements at regular intervals throughout the whole thing. Honestly, this interval tracking is the secret sauce. It's what allows us to see the actual curve of the cardiovascular response rather than just looking at the finish line.
Moving on to part 2, setting your baseline, or the before picture. So on your assessment sheet, the very first thing you do is meticulously record the basic data. You've got the date, the time, and the participant's details. But the absolutely essential clinical context comes from the weight, the height, and most importantly, the resting heart rate. This baseline is basically the anchor for our entire experiment. It gives us the crucial benchmark we need for the spikes that are about to happen. I mean, think about it. A resting heart rate of 60 jumping up to 140 is a wildly different story than a resting rate of 85 jumping to 140.
All right, part 3, the endurance test. Time for some aerobic strain.
The main focus here is this tracking grid on the assessment sheet. We've got our pre-test baseline and then a 5-minute tracking grid. Minute 1, 2, 3, 4, and 5. For the endurance portion, we're using the bench step. And I want you to just imagine these blank spaces filling up with rapidly spiking numbers minute by minute. You're logging the bench step reps to ensure the effort stays consistent while simultaneously capturing that jumping heart rate and the shifting blood pressure as the aerobic system is pushed harder and harder, just trying to deliver oxygen to those working leg muscles.
Now for part 4, the strength test, dealing with resistant strain.
To anchor this concept for you, just look at the strength exercise our source protocol dictates, the classic push-up. This forces your cardiovascular system to battle a completely different kind of resistance. You aren't just moving your legs rhythmically anymore. You're creating intense, localized tension in your upper body and core. And that tension literally squeezes the blood vessels in those active muscles, which creates this incredibly unique pressure environment that your heart now has to pump against. And when we look at the tracking grid for the strength exercise, notice the subtle shift here. We're still tracking the full 5 minutes, and we still record the pre-test numbers, the heart rate, and the blood pressure. But instead of bench steps, we're tracking push-up reps per minute. This lets the assessor see exactly how localized muscular fatigue impacts the cardiovascular response. Like, as those push-ups become a total grind to complete around minute 3 or 4, what happens to the blood pressure? It is just a fascinating correlation to track in real time. To connect this directly to everyday life, let's compare the two. Endurance exercise, like the bench step, is basically simulating the cardiovascular strain of sprinting to catch a bus. Your whole body is moving, and the demand for oxygen is high and systemic. On the flip side, strength exercise, like push-ups, simulates the strain of picking up and carrying incredibly heavy groceries. The oxygen demand might not leave you gasping the same way, but the internal pressure and the muscular resistance creating massive, localized challenge for your heart. Comparing the data from these two grids shows us exactly how adaptable our biology really is.
Which brings us to part 5, tracking your recovery, or as I like to call it, the comeback. At the bottom of both assessment grids, for both endurance and strength, we've got these final data fields. The assessor has to record the precise recovery time for the heart rate, the precise recovery time for the blood pressure, and drop in any final remarks. Basically, you're sitting there with the stopwatch, watching the monitor drop from 150 beats per minute to 120, down to 90, literally logging the exact moment those numbers finally stabilize and return to the baseline we established all the way back in step 1.
Now, here is a super interesting variable straight from the source material that really takes this whole experiment to the next level. The protocol actually states that participants can examine the effects of different types of strength training, specifically looking at whether changing the rest period between sets of resistance exercises alters those blood pressure and heart rate measurements. So you aren't just locked into one rigid test. You can tweak the variables. You can observe how your cardiovascular system adapts to, say, a 30-second break versus a full 2-minute break.
So that leaves us with this final thought. If you actually play with those variables, if you change up your rest periods, how dramatically will your own heart rate adapt? Will a shorter rest cause a compounding spike in your blood pressure, or will your body efficiently manage the strain? Well, you've got the assessment sheet requirements, you know the method, you know the aim, so it's time for you to step off the screen, gather up your equipment, and run your own test. Thanks for joining me for this explainer, and hey, happy experimenting.